Peter Kovalski. Peter is from MinCarb and will be pitching around low energy water treatment. So Peter, please come to the stage via the virtual limousine.
Okay.
Excellent. Hello, Peter. How are you?
Hi, everyone can see me okay?
Yes, excellent. Take it away.
Great. Hello. So I'm Peter. I'm the co-founder of MinCarb. I'm actually based in New Zealand at the moment. So hi from New Zealand. Next slide. Okay, so the technology I'm going to talk about today is a new and emerging technology in the sphere of desalination. So the technology in particular is called capacitive deionization. What it is it's a technology comprised of activated carbon that's used to absorb salt. It's very low energy and it's low cost. It's ideally suited for brackish water treatment, so removing low levels of salinity. It's in fact very competitive in that salinity range when compared to reverse osmosis. So what you can see on the slide at the moment is a typical system that treats brackish groundwater. The system is typically comprised of thousands of layers of this electrode material. Running off solar panels, typically they can be driven at about 1 to 1.5 volts of energy. So photovoltaics are ideal for driving this technology when you compare to, say, reverse osmosis, where you need a considerable amount of energy. Next slide. So a little bit about the progress of MinCarb. We got started in 2012. So just to give you a bit of a reference, when I talk about the progress of the technology, I like to use the ARENA technology readiness levels as a reference scale. And what you see here is how it progressed since 2012. So having, an initial idea about the technology and then advancing to starting a company in 2013 after realizing early the potential. In 2015, we managed to secure an ARC linkage grant. And then later on, moving to sort of levels of commercial readiness, we were quite fortunate to get some seed funding from Tata Corporation to develop this technology for remote communities in India. Where we're at today is we're looking to use this technology to treat groundwater affected with seawater intrusion in coastal regions of the Pacific. So in particular, Vietnam is one of our target areas. Next slide. So the business model is fairly simple. We will be relying on the sale of turnkey systems to provincial governments, medical centres and schools, where they're looking to either apply the technology at municipal scale or at very small scale. So for example, for a medical centre, it's something in the order of 100 litres per day, so a very small system. That would be probably the size of a couple of suitcases. So next slide, just onto the impacts at the moment. So we're looking to make an impact at several scales, small scale, municipal scale, and in the agricultural space. The main target initially is where the need is to develop or to apply the technology. And in particular in Vietnam, there are huge problems with seawater intrusion in coastal drinking waters. And where we're at the moment is we would like to set up a demonstration plant on Ly Island, which is a coastal community in the middle of Vietnam that have a drinking water plant, but it is affected quite severely by salinity and they've had to shut it down. Reverse osmosis is too expensive, but according to our calculations, this technology is actually going to be cost effective. And then you can see a range of impacts there, particularly in 6 and 13. So 13 being addressing seawater intrusion as a result of sea level rise. Next slide. So these are just some of the key people involved, both in New Zealand, Australia, and Vietnam. Next slide. and some key partnerships, including the University of Waikato. TQM is our manufacturing partner on the ground in Vietnam, and our client is the Centre for Rural Water and Environmental Sanitation of Quang Ngai Province. Next slide. So our needs initially is to set up a demonstration plant in An Vin Commune on Lee-Son Island. So we require about $100,000 to complete this demonstration project with co-funding from AWP as well. So they've committed to investing $90,000 in this project, and then later on looking to deploy the technology to other problem areas as shown there, where we would scale up our capacity. Next slide. And final slide. There's my contact details. Thank you very much.